Welcome to the sixth session of the second module. Now, actually, in the previous sessions, from the first to the fifth sessions, we have discussed the various types of boilers and various types of turbines and their working principle and comparison with its counterparts. Now, this sixth session is majorly concentrated on the third chapter of the second module, which will be concentrating on the pumps. Now, when we categorize different types of machineries, we always broadly classify into two categories. One is power consuming and the other one is power generating devices. In the power consuming devices, they will consume the power externally and does the work for us. It may be mechanical work or it may be any form of work. It just consumes the external work and it generates work for us. In case of power producing devices, it just consumes it consumes some external mechanical work and generates electricity for us. That is what as a power generating device. It generates a power at the cost of work. Power consuming, they consume power and they does the work. That is the major differences. Okay, now in power generating, we have discussed turbines. All the turbines comes under the category of whether it may be a wind turbine or it may be steam turbine or it may be a hydraulic turbine or it may be a reaction or impulse, any type of a turbine. When I say it is a turbine, so it is power generating. It takes work and generates power. The power absorbing devices, there are plenty of power absorbing devices are there, whether it may be heat exchanger or whether it may be condenser or it may be pumps, okay, or it may be a boilers. What they will do it is they will take the energy from outside and convert one form of energy to the other form of energy. They consumes the power and they does the work. Okay, now let us talk about the pump. Pump is one of the interesting element or a device in mechanical engineering. These pumps plays a vital role in hydraulic systems. These pumps plays a vital role in a pneumatic systems. In a hydraulic systems, in JCBs, and even in the power plants. In every sector where the fluid movement is there, the hydraulic pumps plays a very major role, including for the domestic applications where regularly we pump the water from the sump to the syntax. Is that clear? So this is the major advantages of these hydraulic pumps. Now in this session, let us talk about the hydraulic pumps, types of pumps, and then pumping theory. There are different types of pumps are there, in which we will talk about only the hydraulic pumps. The role of pump is to transfer the mechanical power into the hydraulic power. So the electric power is converted into mechanical power and then mechanical power into hydraulic power. So that is what the energy transformation, that is how it does takes place. Now if you consider the role of a pump is to transfer the mechanical power into hydraulic power by increasing the pressure of the pumped fluid or forcing a flow. A hydraulic pump is a mechanical source of power that converts mechanical power into hydraulic energy. This is what I just meant to say. Hydrostatic energy, that is a flow or a pressure. Okay, it generates flow with enough power to overcome pressure produced by the load at the pump outlet. Now let us talk about different types of pumps. There are varieties. There are around so many types of pumps are available. Basically, we will categorize it in a broad way. Okay, not in detail. It's in a broad way. We just let us try to categorize it. They are a positive displacement based on classifications. First one is a positive displacement pump, which are also called as a hydrostatic pumps, and non-positive displacement pumps, which comes under the category of hydrodynamic pumps. Also, there are two types of positive displacement pumps, and those are rotary pumps and then the reciprocating pumps. The positive displacement major classification is positive displacement and non-positive displacement. Even in this positive displacement pumps can be further classified into basic principle of working, that is a rotary pump and reciprocating pump. Rotary pump is the one which will have a mechanical energy, or the rotational type of mechanical energy will be existing. Whereas in a reciprocating pump, the mechanical energy will be transferring from to and fro motions, something like this, something like this. This is called as a reciprocating motion, and this is called as a rotary motion. If the pump is working basically on this rotary action of rotors, then we call it as rotary pumps. And if it is piston and cylinder arrangement is there, if there is a piston and cylinder arrangement, then we call it as reciprocating pumps. Even in this rotary pumps, a single rotor pump is also there. For example, piston pump, vane pump and screw pumps. Okay, and then multiple rotor pumps. If more than one rotor is there, then we call it as a multiple rotor pumps. For example, gear pump and then the lobe pump. Reciprocating pumps, in the reciprocating pumps, it can be further classified into diaphragm pumps, for example fluid operated pump, and mechanically operated pumps are also there. And then piston plunger type of pump, as I just told you, like a piston and cylinder arrangement, as we will have it in IC engines, which we will discuss in the next module. Okay, then and again the dynamic pumps can be classified. Positive, after this positive displacement, these dynamic pumps can also be classified into two more types, that is centrifugal pump and then axial pump. So these are all the different classifications. If you want to have a further classification in the non-positive displacement pump, it is also called as NPD, or the dynamic pump. Okay, positive displacement are also called as static pumps or a hydrostatic pump, whereas the non-positive displacement pump are also called as hydrodynamic pumps. See, the positive displacement are classified into rotary and reciprocatory, and it is further classified. And in the dynamic or a non-positive NPD, it is classified into centrifugal and axial. Now let us talk about the non-positive type of pumps, or it is also called as the dynamic pumps, where these pumps are also known as hydrodynamic pumps. In these pumps, the fluid is pressurized by the rotation of the propeller, and the fluid pressure is proportional to the rotor speed. How much ever the speed with which it rotates the rotor or a propeller, so much of the pressure will be built up. Is that clear? That is the reason why even when you go for the purchasing of any pumps, its capacity or its configuration also differs. Is clear? So that is the reason why the rotor speed will decide directly with the fluid pressure. Higher the rotor speed, higher the fluid pressure. Lower the rotor speed and lower the fluid pressure. So when we have, say for example, if you have a syntax in the first floor, whatever the pressure with which it has to pump is very less. Maybe 1 HP is more than enough. Say for example, if it is much less, then half HP is okay. And when you go for the third floor, fourth floor, and if you go for any the multi storied buildings where the 15 stores, 16 floors, 20 floors will be there, then the same 1 HP pumps will not be useful. So what it will decide is, it will the power with which it rotates. Then we will have to go for a higher rotor speed pumps, which has to give more fluid pressure so that it should go to the such elevations. Okay, these pumps cannot withstand high pressures and generally used for low pressure and high volume flow applications. High volume but not the pressure. Is it clear? That means more amount of discharge, more amount of water can be displaced, but not the pressure with which it has to go. When we go from multi-storage, we cannot go for non-positive displacement pumps because it cannot generate more pressure of the fluid. These pumps cannot withstand high pressures and generally used for low pressure and high volume flow applications. This is what I meant to say. The fluid pressure. The, basically, my dear friends, whenever I talk about a fluid stands for a combined terminology used for indicating it may be a gas or it may be a water or that may be liquid. It can be gaseous or it can be liquidous. Are you getting my point? So whenever I say water, it comes under the category of fluid. Whenever I say it is air, it will also comes under the category of fluid. When I say liquid, only I will talk about liquid. When I talk about gas, the vapor state or a gaseous state, then I will talk about only the gases. When I talk about fluids, that means it includes both liquid and gases. This is the one opportunity very much I wanted to highlight this point. What do you mean by a fluid? That's it, okay? But here we are talking only with related to the hydraulic pumps. That means water, the pumps which are extensively used for water. Okay. Now, if you consider this, the fluid pressure and the flow generated due to the inertia effect of the fluid motion is generated due to rotating propeller. These pumps provide a smooth and a continuous flow, but the flow output decreases with increase in the system resistance, that is the load. System resistance is nothing but the load on which. What do you mean by load? Maybe the pressure we are looking out for the fluid, or maybe the elevation we are looking out, or maybe the quantity. These are all called as a load. For a pump, what do you mean by load? It is nothing but the elevation what we are looking out, or it may be pressure of the fluid, or it may be the quantity of the fluid which we are expecting for the dispatch or the discharge. That is what we call it as the load. The flow output decreases because some of the fluid slip back at higher resistances. Okay. The fluid flow is completely stopped at very large systems resistance, and thus volumetric efficiency will be zero. Is that clear? Therefore, the flow rate not only depends on the rotational speed but also on the resistance provided by the system also it depends. Okay. The important advantages of non-positive, that is NPD pumps, are lower initial cost. The initial cost is very less, and the operating maintenance cost is also very less. Because of the less moving parts, what happens in a piston and cylinder arrangement? What happens? It will move it into very fast rate. Whereas here, the moving parts are limited. Whenever we have a moving parts limited, so what happens? The maintenance cost is less. The vibrations which are generated during this is less, and when the vibration is less, the foundation which is required to operate this will also be less, and obviously the cost for having this is also less, and it also gives a simplicity in the operations. Is that clear? So higher reliability is also there, and simple operation procedures, that as I have already told you. And then suitability with a wide range of fluids, not only water. These are also can be used in hydraulic systems. Hydraulic systems you might have seen in JCBs, you might have seen it in the earth movers, you might have seen it in the cranes, or you might have also seen it in automatic opening and closing of the doors. So hydraulic applications are very vast. So these pumps can also be used with varieties of the fluids. Different fluids can be worked under these conditions. These pumps are primarily used for transporting fluids and find a little use in the hydraulic or the fluid power industries. Centrifugal pump is a common example of non-positive displacement pumps. Centrifugal pumps comes under the category of non-positive, or they are also called as the hydrodynamic pumps. So let us talk about the positive displacement pumps. These pumps deliver a constant volume of fluid in a cycle. The discharge quantity per revolution, that means the amount of fluid that is being discharged per one revolution, is fixed in these pumps, and they produce fluid flow proportional to the displacement on the rotor speed. These pumps are used in most of the industrial fluid power applications. The output of fluid flow is constant and is independent of the system pressure. Independent of the system pressure, that is of the variation in the load, the output of fluid flow is constant. Whether it may be a lower load, that is the fluid flow will be same. Whether even in the higher load, the fluid flow will be constant. That means irrespective of the variation in the load, what happens, the pressure variation in the load, the output of fluid will be same, it is constant. The important advantage, the major advantage of the positive displacement pumps over a non-positive displacement pumps include that the capability to generate high pressures. This is what is important. I was just talking, if you want to pump the water for the first floor, it is okay. If you want to pump the same water to the 20th floor, so what is this elevation? When you want to have so much of elevations, you need to develop more pressure. You need to develop more pressure for the pumping fluid. So that can be generated. That can be generated only using the positive displacement pumps, because the non-positive displacement work effectively for low pressure, high volume, whereas these positive displacement pumps or static pumps can work for a higher pressure of the fluid. So these points are very significant applications. Okay, now this is the major advantage is that it includes capability to generate high pressures of the fluid, high volumetric efficiency, okay, high power to weight ratio. The power which is being utilized based on the weight ratio, it comes to be very high. Change in efficiency throughout the pressure range is small. That means change in efficiency doesn't occur. That means it will be a very good, consistent, efficient pumps. It works throughout the range. It works with the minimum, that is a constant efficiency, because the output of the fluid flow is constant irrespective of the variation in the load onto that. Change in efficiency throughout the pressure range, change in the efficiency, that is what, throughout the pressure range is small. Variation in the pressure doesn't affect the efficiency. And wider operation range of the, it can operate it in different ranges of the pressure. It can vary, the pressure can be varied with different one, and even the speed can also be varied using this. Then the important positive displacement pumps are gear pumps and vane pumps. There are different working principles actually. In gear pumps, what happens, there will be once again internal and external gear pumps will be there. Have the gear which rotates like this. When it rotates, you just imagine two gears, when it rotates like this, it creates a suction at the top. If it rotates like this, what happens, it creates at the suction. Ultimately the aim in the pump is to create the suction. Now one small example I'll tell you. If you have a tender coconut with a straw, unless otherwise you suck it, you create the pressure, the tender coconut, the water will not go into your mouth. You have a tender coconut and you have a straw, you keep it in your mouth, but still the air will not go into your mouth. It is only because you have to create the pressure. The same thing even in the pumps also, you have to create a suctional pressure, or you have to create a vacuum pressure, or you have to create the pressure more than the atmospheric pressure. Then what happens, it just comes in automatically. Now the pressure with which we create depends upon various factors. Based on that also we have made a classifications over here, wherein the gear pumps which are most used, and these can be further classified into external gear and internal gear, and can also be classified into lobe gear. Lobe is nothing but a soft curvature shaped gears only, and then the lobe pump, and then screw pumps are also there. Why it is called as a screw pump, because the principle of action is something like a screws only, threading will be there. Okay, now the second category is the vane pumps, and even in the vane pumps we can classify this into balanced and unbalanced. A balanced one is one which is been balanced with the mechanical forces of action, and unbalanced one Vane pumps are also there, and then the piston pumps are there. Piston pumps is an axial design, and then the radial design. Axial design is the one where in which it will be like this, where the piston and cylinder will act in axial directions. Piston will comes and hits and goes back. It comes back, goes back. It is something like our syringe, injection syringe. As you just take it, pull it backwards, it creates a suction. It's a one more example that you just inject it. How you take the medicine in a syringe? You just inject it and then you will try to pull that lever backside. As you are pulling it backside, it creates a suction so that the medicine will fill up it in the syringe. So the same thing, it is nothing but an axial design. If all these syringes have been arranged in a radial direction, like a circular direction, then we call it as the radial designs. This is a one pumping theory which is very important one. As you can look at this is a piston, and this is a complete cylinder, and this is a rod which just pulls it and pushes, and it will have a reciprocating motion. Now pumping theory, he might ask you as a question, with a neat sketch you have to explain the pumping theory. Please be careful over here. Now there will be an inlet valve and there will be one outlet valve. Okay, now this is first position. What happens is, this is a oil tank, or it may be a water tank, or whatever it may be. The liquid which is being stored over here will be at atmospheric pressure. What is the atmospheric pressure? It is 1 bar, or it is also 101.325 kilopascals. 101.325 kilopascals. If this water or a oil or a fluid has to come to this, means you have to create more pressure, or you have to create a suction pressure. That means the pressure which is being created over here should be less than this atmospheric pressure. Then automatically it flows over here. You should create the pressure which should be less than the atmospheric pressure. This is how we are just reducing the pressure, or we are just decreasing the pressure than the atmospheric pressure. Now through this inlet valve, what happens? This is something like a, once this piston moves backwards towards the left, what happens? The pressure inside this cylinder will be decreased less than the atmospheric pressure. So it will be less than 101.325 kilopascals. So that what happens? The oil will automatically takes inside of this. Once it fills, the piston takes the leftmost position. The piston will come to the position of 4 or beyond this 4. So that what happens? The oil or a fluid will be completely filled into this. Once it is being filled, the inlet valve will be closed. The inlet valve will be completely closed, and then what happens? The rod will start pushing towards the right side. Once if it starts pushing towards the right side, the outlet valve is closed and the inlet valve is closed. So what happens? The oil will be compressed. The oil or a fluid or a water will be compressed to a higher pressure. So what happens? This creates a pressure more than the atmospheric pressure. So while suction, the pressure is less than atmospheric pressure. Once it has been compressed, the pressure will be more than atmospheric. At that end of this position, what happens? The outlet valve or a discharge line will be open. So because the pressure is more, what happens? The rod is moving towards the right side, the pressure of the fluid keeps increasing. Since the pressure is more, automatically it moves through the discharge line or an output line or an output valve or an outlet valve. Is it clear? This is nothing but a principle of pumping principle. As the piston moves leftwards, the pressure decreases. From the oil tank, the oil will enter into this section. As the piston moves from left towards the right side, what happens? The pressure increases and the oil will go to the discharge line. This is called as a pumping theory. Now my dear friends, you have to explain this compulsory with the figure, and you have to explain this. Pumps operate on the principle where by a partial vacuum is being created. Vacuum pressure or a suction pressure or lower pressure than the atmospheric, it is all the same things. Is that clear? At the pump inlet, due to the internal operation of the pump, this allows the atmospheric pressure to push the fluid out of the oil tank and into the pump intake. The pump then mechanically pushes the fluid out of the discharge line. This type of operation can be visualized by referring to the simple piston pump of figure. Note that this pump contains two ball check valves which are described as follows. That is check valve 1 and check valve 2. This is the check valve 1 at the inlet and the check valve at the outlet is 2. What do you mean by check valve? Check valve I have already told you in explaining the boilers. It is something which is something like which stops. It is something a gate which restricts the flow of the fluid. Now the pump then mechanically pushes, check valve 1 is connected to the pump inlet line and allows the fluid to enter through the pump only at this location, and this check valve 1 will not allow the fluid to go back to the oil tank. It is only a one way. Okay, now here even the check valve 2, it will allow only the oil to go to this discharge line and it will not allow to come back. So that is the use of this check valve. Check valve 2 is connected to the pump discharge line and allows fluid to leave the pump only at this location. As the piston is pulled to the left, the partial vacuum is generated in the pump cavity 3 because the close tolerance between the piston and the cylinder prevents air inside the cavity 4. Okay, from the traveling into the cavity 3, the flow of air is allowed to occur, would destroy the vacuum. That is the reason. The vacuum holds the ball of the check valve 2 against its seat and allows the atmospheric pressure to push fluid from the reservoir into the pump via the check valve. It is only because the pressure is inside the cylinder is much less than the atmospheric pressure. This inlet flow occurs because the force of the fluid pushes the ball of the check valve 1 off its seat. When the piston is pushed to the right and the fluid movement closes it, inlet valve 1 and opens the outlet valve 2. The quantity of fluid displaced by the piston is forcibly ejected out by the discharge line leading the hydraulic system. The volume of oil displaced by the piston during the discharge stroke is called the displacement volume of the pump. Okay, so this is what the working principle is. Okay, I have few MCQs. Before that, I just would like to explain this in particularly. Now, what happens here? As the piston moves left and moves to the right, according to the movement of the piston also, these check valves have been fixed. Basically, what you can see it here is there is a small ball and a flat rectangular plate is also there. That means whenever the inlet suction is created, it automatically lifts because of the suction and the oil pump will go over here. Meanwhile, since the pressure is from this end, this will be closed. The outlet valve or check valve will be closed. At the meanwhile, once the piston starts moving towards the right side, what happens? So it will be creating a very high pressure. Very high pressure makes the valve to shut down. That means check valve will close this valve. As these positions, you can see it here. The check valve at 2 and the position of check valve 1 will be always in the opposite directions. Once this pressure comes and closes over this, the high pressure makes this valve to open and low pressure makes the valve 1 to open and high pressure makes the valve 2 to open. So this is how it just operates. And this check valve plays a major gateway line between operating the fluid. Okay. Now regarding this operation, we have got few MCQs, most frequently asked MCQs. Let me go through with a few of at least 3-4. Which among the following are not the main selection criteria for selection of the hydraulic pumps? Now basically, based on the discharge, that is the quantity I have been repeating, based on non-positive displacement are very good on the discharge, correct? Based on the discharge or the quantity, discharge is nothing but amount of liquid it has been discharged per second, that is meter cube per second. Based on that, we will select it, correct? First point. Pressure, we select it, obviously. Based on the pressure, which is been required, we select it based on the speed. Higher the speed, higher the fluid pressure. So obviously speed and pressure are one interrelated. Okay, now weight is not. Actually, we don't consider the weight while selecting the hydraulic pumps. So the option is D. Which type of the mechanical device is used to give energy to the liquid? Obviously, it is a hydraulic pump. No need to discuss it itself, because a hydraulic turbine is nothing but power generating. Air compressor is also doesn't comes into IC engines, also doesn't comes into picture. So it is a hydraulic pump which has been used to give energy to the liquid. Air compressor, it is for the gases. IC engines, it is an engine, not a pump. Okay.